Okay, good morning to all of you. So, today, probably many of you people have not joined yesterday. So, that's why I'd like to repeat the previous class with more and more, so, more and more clarity. So, let me start the class. So, we have started unit number 4, synchronous sequential circuits, synchronous sequential logic, which is useful to you to store data. For data storage, synchronous sequential logic is supposed to be used here. And here, synchronous sequential logic also includes the combination circuit. And of course, we know combination circuit might have several number of inputs. How many number of inputs will be there here? N number of inputs might be there, and it does have several number of outputs. How many outputs in the sense? As per the basic point. So it is 2 power m number of 2 power n number of so outputs. Otherwise, you could consider it as so m number of outputs, where m will be less than or equal to 2 power m. M number of outputs, which is less than or equal to 2 power n. So this is the point you need to remember in terms of combination logic. Whereas in combination logic again, so here there is no, outputs could not be affected any input here. So state of output must be depends upon current value of the input. If current value of input some pattern, so based on the particular pattern, you could get the output for combination circuit. So what does it means? Any output, this output could not be affected the input of the or working principle of the combination circuit here. Output could not do anything in combination circuit. So if you add to the combination circuit, if you add a memory unit, a small memory unit, which could be able to store exactly 1 bit of information, then this entire structure will be called as sequential logic. So as and when you have to listen or you have to heard this particular word sequential logic, you must remember in sequential logic, so output of this memory unit will be given as feedback to the input of your combination circuit. Output of this memory unit will be given as a feedback to the input of combination circuit. Therefore, output of this memory unit must affect the working principle of this whole logic here. In sequential circuits, output must be affected the inputs of the combination circuit or sequential logic here. So this is the basic difference between first basic difference between the combination logic and sequential logic. Second basic difference is in sequential logic we do have n number of inputs and m number of outputs, whereas in sequential circuits we have n number of inputs, but outputs might be only 2. Either output will be, so normally we have to mention as q. So q in its ordinary form and q in its complementary form also. These two will be available as outputs in sequential logic. So inputs will be n number of inputs might be there, probably 2 inputs, probably 3 inputs, probably 1 input, something like that. N number of inputs might be there, but you have the output as q, its original form, and another output as q complement. However, we would like to consider only one output. Of course, it must be available in ordinary form and original form and its complementary form. So this is the second difference between combination logic and sequential logic. Okay, let me repeat one more time. In combination logic, number of inputs will be n and the number of outputs will be m, which is less than or equal to 2 power n. Whereas in sequential logic, so In sequential logic, number of inputs might be n, and outputs must be, so its original form and its complementary form. Only these two. This is the first difference. Second difference is in combination logic, present state of inputs can be only taken into consideration based on the present state of inputs you have to produce output. Whereas in sequential, present state of, in addition to present state of inputs, you must also take the output as one of the inputs here. So that is the point you need to remember. So that is the only point I have mentioned here with respect to the data which has been given here. So it is always used to store some kind of binary information, and sequential circuits is always used to store the information. More and more specifically, it could be stored one bit of information only, single bit of information only, not more than that. And sequential circuits must be receive the external inputs, and present state of output also be so taken into consideration. Based on that, it could be produce the output. And so external inputs might be defining by taking so state in storage. State in storage in the sense, so what exactly the present state, that present state will be taken into consideration, and together to present state of information, so you maybe take some external inputs also. And here finally sequential circuit is specified by the time by a time sequence of inputs, outputs, and internal states also. Internal states in the sense external outputs which have been generated just before. They are called as internal states. They will be called as internal states. Now, so if you consider sequential circuit something like this, if you add a clock pulse, something like this, then it is a fully sequential circuit. If you are not supposed to add a clock pulse, that could not be fully sequential circuit. So if you add a clock pulse to the memory unit, then that will be called as a fully sequential circuit. Then how this could be gets evaluated? So this clock pulse will be generated something like this. When it will be touched to the ground, it will be called as 0. When it will be up, so then it is it is 1 actually. It is not 0. So it is 1, and so on and so forth. This is 1, and again it touch to ground, and it is up, and so on and so forth. So like this, you have to mention your values here as and when. So if you consider one clock pulse in the sense, so the clock pulse which is available from here to here will be called as one clock pulse. 0 combination of 0 and 1 will be called as one particular clock pulse here, and so on and so forth. Okay. Then how this could be implemented? Let us have a look. The previous class, in the yesterday's class, I have taken. I haven't drawn anything in PowerPoint. Right now, today, I have drawn each and every point, and you please follow it. So normally, SR latch will be very important. Using this particular latch, we may be implement all flip-flops. So SR latch will be implemented by using NAND gate with the following structure. First NAND gate and the second NAND gate. So first NAND gate might have one input, which is external input, and the second NAND gate also have one more input, which is external. And the first NAND gate might have one output, and here also second NAND gate also having one output. And output of, first NAND gate input will be yes, and second NAND gate input will be R. Output of first NAND gate will be connected to, output of second NAND gate will be connected to, so first NAND gate as a feedback, and output of first NAND gate will be connected to second NAND gate as a feedback here. However, for the two different kinds of NAND gates here, first NAND gate and second NAND gates, one of the inputs must be output of the previous state. Previous state in the sense, previously Qn will equal to 1 and the Q complement n equal to 0. In the sense, this 0 will be submitted here and this 1 will be submitted here. After some time, it may be changed to, so it is 0 and it is 1 in the sense, 0 will be submitted here and 1 will be submitted here. So sequential circuits must be always take present output also, present state output also as one of the inputs of one particular gate here. So that is why it is called as a sequential circuit. Then how this could be gets evaluated, and what are the different kinds of states which are being available. So let us have a look here. we do have two different types of inputs are there. If you have two inputs, totally four different kinds of combinations will be there. 0, 0 is one combination, 0, 1, 1, 0, 1, 1. These are the four combinations. How this could be gets worked out here? Let us have a look here. So look at this case one. If s equal to 0 and r equal to 0, should I have discussed, but you may not follow because I am writing using my mouse. Probably you may not follow me, so that is why I have created a small slide for you, so it could be somewhat better for you to understand. Because understanding of this is very important for moving to further topics of this particular unit. Okay, s equal to 0 and r equal to 0. Then, so here we need to identify this is the present state. So during s equal to 0 and r equal to 0, output of first NAND gate will be Qn. We don't know what is the value of Qn, but you have to consider that it is Qn. And output of second gate will be Q complement n. We don't know what is the value of Q complement n here. So don't consider, so this is some particular value. You just have one is original form and second one is so complementary form. These two are available with us. Now, so here it is 0 and here it is also 0. Now, you are expected to identify next state. Next state in the sense, right now n, so next state will be Qn plus 1. Qn plus 1 is supposed to be evaluated by you. So how this could be evaluated? Qn plus 1 will be equal to 0 into one of the inputs is 0. Second input is Q complement n. We don't know what is the value of Q complement n at this moment, but we have been submitted here. So 0 into Q complement n. So 0 into everything is 0. So therefore 0 complement, which is equal to 1 here. It has been produced as 1. And also check about this particular value. So look at this Q complement, Qn plus 1 complement. If you consider Qn plus 1 complement, so one of the inputs is 0 here. So this input is 0. So I have taken Qn directly. Instead of Qn, you are also expected to submit 1 also. There is no problem at all. But let us consider so Q into, so 0 into Qn whole complement. 0 into anything will be 0. So 0 complement will be equal to 1. Look at this. It is actually, Qn is actually ordinary form and Qn plus 1 is its complementary form. We never come across this kind of situation. Qn is equal to, Qn plus 1 value equal to 1. And so intuitively, Q complement n plus 1 must be 0 actually. Okay, Q will be, for example, if you take A, value of A will be equal to, so 1 in the sense, obviously A complement value must be equal to 0. Otherwise, in the converse way, so A complement will be equal to, so 1 in the sense, obviously its original form must be, so 0. This is the general point of view when we consider about binary information. But here you could see, so Qn plus 1 value is equal to 1 and Qn plus 1 complement value also equal to 1. So it could not be existed as far as number system theory is being considered. So this case is called as forbidden case. You could not achieve such kind of case here. So therefore, as and when 0 zeros will be available with this SR latch, you could not get any kind of value as output. Okay, this could be considered as forbidden case. It could not be taken into consideration. Whereas, so this case could not be. You must take care while designing any kind of circuit. So using NAND gate, something like latches, you must be take care. So S and R values must not be equal to 0. Okay, if these two S and R, not SRR. SRR in the sense either S will be 0 or R will be 0. That case is okay. But S and R, both values will be equal to 0. So you never get the output from this particular latch. So that latch, the state of that particular latch will be forbidden state or indeterminate state. It could not be determined what kind of value. So therefore, you whenever you are trying to construct such kind of thing, you must be take care S equal to 0 and R equal to 0 case should not be there in our construction. Then forward by case 2, S equal, just change the values, S equal to 0 and R equal to 1. At this moment, we would like to consider, so second case here, case number 2 will be, so S equal to 0 and R equal to 1 here. Now, let us examine what are the specific values which are being available at this moment. Now inputs of this particular thing will be, inputs will be, here it is 0 and here it is 1 actually at this moment. So outputs of this particular circuit will be Qn and Q complement n. So one is Qn and second one is Qn complement. So let me evaluate this particular gate first gate first. So if you evaluate the first gate, so whatever the output you can see Q, so you are expected to identify. So Q n plus 1. Next delta time will be expected to evaluate here. If you want to evaluate this one, 0 into one input is 0 here. One input will be here, it is 0. Second input is being connected from here to here. Second input will be Q n complement, Q n complement. 0 into anything will be 0. So 0 complement equal to 1. Yes, you got 1 here. And second point will be Q n plus 1 complement will be equal to 1 into, so input will be, okay, whatever the value you have got right now, you just don't bother about that one. So directly submit only this particular value. So submit this particular value here. Obviously one input is 1 and second input is who is this Indrasena? Who is this Indrasena? Just wait for a while. I will eliminate him from the class. What kind of words you are using here? Okay. So you have to submit this one here. So one. So first one is 1, and this input is, this one input will be, so Qn. So 1 into Qn, so will be equal to Qn whole complement will be equal to, so whole complement. So Qn whole complement will be equal to 0 here because we got 1 just before. So 1 into 1 whole complement equal to 0. So this particular value is 0. It is eligible. So therefore, when so 0 and 1 will be there, s equal to 0 and r equal to 1. So whatever the output you have, your value could be set to, so 1 here. You can observe this one. Your value could be set to 1. Okay. So obviously, if Qn equal to 1 in the sense, it must be Q complement must be always 0. Yes, your value could be set to 1 here. And when s value equal to 0 and r value equal to 1, your value must be set to 1. Then case number 3, third case. Let us examine this particular case here. This case will be also some, okay, wait for a while. Yes. So this particular case also be taken into consideration. S equal to 1 and so R equal to 0. This case will be taken into consideration. This is 1 and this is 0. We don't know what is the value of Q complement n at this moment because we have freshly submitted these two inputs here. So here you can see, so Qn complement. So Qn complement will be submitted here. So therefore 1 into Qn complement whole complement because NAND gate will be A into B whole complement. So that 1 into Qn complement, so whole complement will be taken. So 1 into, so Qn complement equal to Qn complement. For example, if this value will be equal to, so 1 into 1 whole complement, so that you could get Qn equal to 0 here. Okay. So whatever the value you have, if it is 1, it must be equal to 0. Understand? It must be equal to 0. If you take such kind of values as input, so instead of Qn complement, so if you maybe submit here 1 and here also submit 1. So 1 into 1 whole complement, 1 into 1 whole complement equal to 1 complement. 1 complement in the sense the value is 0. And obviously this 0 will be submitted here. 0 into 0 whole complement, 0 complement equal to 1 here. So look at this. 0 into Qn, whatever the value of Qn, that could not be taken into consideration because the operation which could be took place in between these two are 0. So 0 into anything will be 0. So 0 complement will be equal to 1. So this case also eligible. So this case also be eligible. So however, as and when s value equal to 1 and r value equal to 0, the state is called as a reset state. So previously it has been Qn value equal to 1 here previously. I'm talking about previous state. So when values will be, for example, if you take this particular value, so qn, well, qn plus 1 value equal to 1 and qn complement value equal to 0. So that 1 has been set to, so 0 here, that 0 has been set to, I mean this 1 has been set to 0 here. What does it mean? Nowadays everybody is riding some bikes, thereby some daily ride in dynamo daily ride will be there. If you I mean push one particular button, so some number of kilometers will be there that will be set to 0. That will be set to, that is called as resetting to 0. Today in the morning to evening you may be ride somewhere else, right away from your house to college to somewhere else, and somewhere else to somewhere else, and so on. Finally maybe reach to home, probably maybe get start with 0, and finally at the end of the day you maybe get some 50 kilometers or something, 60 kilometers, something like that. So that 50 or 60 kilometers will be reset by tomorrow also. So tomorrow also you have to reset, and you have to know that how many kilometers I have taken. So I have ride something like that. So such kind of resets will be happen when r equal to 0 and s equal to 1. Okay, this is called as a reset state. And finally, last and final state will be, let us take into consideration s equal to 1 and r equal to 1. Both will be equal to 1. What exactly been happening here? Let us have a look here. So this both values will be equal to 1. Let me consider. Wait. Yeah. So both values will be equal to 1. So what is the value of qn plus 1? Let us consider this is 1 and this is also 1. So we don't know what is the value of this one. Either value could be there here with the qn complement. So it has been submitted to qn complement. So 1 into qn complement will be equal to, so whatever the value with the qn, the same value can be occurred here. Whatever the value of qn, the same value. So for example, by the time we have to apply, so 1 qn might be, before going to apply this one, qn might be equal to 1, same 1 will be output. If otherwise qn will be equal to 0, same 0 will be output. So you can see qn plus 1 is equal to, so final answer is qn. So therefore that particular value, same value can be gets occurred at this moment. Then qn plus 1 whole complement equal to, so here we have been operated, we have been taken this particular value as input here. So here also we don't know what is the specific value. So 1 into qn whole complement equal to qn whole complement. Qn whole complement in the sense of previous state, just before what kind of values you have been having, same value will be continued for the next state also. So as and when you have to submit, so s equal to 1 and r equal to 1, whatever the previous values which are available with you, same kind of values will be continued. They will be continued. So this is called as no change. There is no change. So when so you have to take the 1 and 1 values here. So these are the 4 different types of states. Because 2 inputs are there, you do have only 4 outputs. So I mean 4 combinations we have been checked. First combination, second combination, third combination, and fourth combination. So we will so recall one more time, otherwise revise one more time. As and when 0, 0 will be there, it is called as forbidden state. We could not expect what kind of output it could be. We could not expect whether the latch is being working properly or not. Okay, because complementary value and ordinary form both will be equal to 1. It is never happens in terms of Boolean algebra. So you must be take a, while designing any latch or any flip-flop, no kind of issue, I mean no kind of inputs might be equal to 0 and 0. Whereas if you take 0 and 1, s equal to 0 and r equal to 1, so the flip-flop will be set position. Whatever the value, whatever the qn value previously, that must be set to 1, and whatever the, so qn complement, that must be set to 0. Previously, whatever the value it may be, whether it is 0 or 1, that doesn't matter. It must be set to 1 here. Qn value must be set to 1 here. Whereas in case 3, so s equal to 1 and r equal to 0, whatever the value which is available with the qn, that must be so reset to 0. Previously set to 1. So here also you could call it as reset, but s is being affected here, so that we have to call it as a set here. And here it is resetting. As and when, if you consider, I will give you one more example for reset. So normally, if any running race will be get started, So normally stopwatch will be gets operated here. Stopwatch will be get started with 0, and people will be run right away from beginning to 100 meters. After 100 meters, you may be get stop over there. You may be calculate or count that particular, note that particular time. And the second team is being start their race, then what you are supposed to do, you must reset it to. So for example, previous set of people are being taken 9 seconds and 25 milliseconds will be taken for run. So that let me say 100 meters. Then second set of people are being start their work in the sense immediately you have to apply for reset. That will be goes to 0 again. Okay, as and when the circuit will be set to 0, I mean the circuit value could be put into 0, that is called as resetting, and the circuit value will be put into 1, that will be called as setting. So that is the general operation is that generally we have to call something like that. So that is why we would like to call it as a reset operation. If you are supposed to submit one and one here, something like this, so whatever the previous values, same values will be continued. Previously qn value equal to 1, so there is no problem, the same value will be gets continued. Previously it will be equal to some 2 some 0, same value will be continued. So that is why it is called as no change. There is no change here. So only problem will be raises when so s equal to 0 and r equal to 0. So this problem also eliminated while what do you call constructing some kind of flip flops. Okay, this could also be eliminated because sometimes, not sometimes, very often both inputs will be equal to 0. Yes, it could be possible. It could be possible. You never avoid this kind of situation. So it could be possible. How could you avoid this forbidden state? You will be learn in future classes, probably by tomorrow. Okay, so this is the functional state, functional table, which is useful for you for what do you call SR latch here. And this is the specification. So look at this. Presently, you are having these inputs. Presently, you are having these inputs. S equal to 1, R equal to 0, Q equal to 0, and Q complement equal to 0. At this moment, if you supply S equal to 1 and R equal to 1, same outputs will be continued. That is the meaning, what I have given here. S equal to 1, right now S equal to 1 and R equal to 0. So you got these two values, Q equal to 0 and Q complement equal to 1. After some time, probably after taking one or 2 seconds, you may change your inputs, S equal to 1 and R also equal to 1. Then whatever the previous outputs you have with you, same outputs will be continued. After some time, you may be change the input something like this. S equal to 0 and R equal to 1. Now your inputs will be seen like this at this moment. Now at this moment, you may be supply, so 1 and 1 at this moment, whatever the previous state of outputs, same outputs will be continued. Same outputs will be continued here. Okay. Previously it is 0, 1, 0, 1 will be continued here. Previously it is 1, 0, 1, 0 will be continued here. So as and when 1, 1 will be gets passed in the sense, what is the previous state of outputs, same outputs will be gets continued. So that is why it is called as no change. No change. That is the meaning here. And if you send 0, 0, so it would be taken the 1 and 1, ordinary form equal to 1 and a complementary also be equal to 1. It never exists. So that is why this format is this form is called as forbidden, and it's also mentioned as indeterminate state, either indeterminate state or forbidden state. Forbidden state in the sense you could not get the value, you could not get proper value. Okay, so here, what do you mean by Qn equal to X in the sense, normally X will be represented in the digital logic design, X will be represented don't care. X or DR2 will be, already I have given some information while we are discussing something about don't care conditions. X will be represented don't care. So while 0, 0 will be there, here maybe 0 or maybe 1, we don't know exactly. As these two situations, you could see at this particular scenario, we do have these values, and at this particular scenario, we do have these values. Okay, so we could not suspect what kind of value here. Probably either 0 or it is 1. So same values will be gets continued. or so value could be set to 1, or value could be set to reset to 0, something like that. Okay, so this is the way you have to identify or evaluate this SR latch. Okay, you need to understand this SR latch very carefully. So this SR latch could not be understood by you. You could not get anything from this particular unit, because this unit is very, very important for you for your next semester also. In next semester, you have one particular course that is called as computer organization. It's very, very important for you. Okay. So this is what today's class, and tomorrow I shall continue with the pure flip-flops. What exactly the flip-flop will be. So here you need to understand there is no third input here. There is no third input. Third input is actually what I have specified here. In the previous diagram, I have specified something. This memory element must be have some clock pulses. Some clock pulse must be there. If you don't have any clock pulse, that could not be considered as a flip-flop. Okay, a sequential circuit. You can see we don't have any clock pulse here. There is no CP. Clock pulse in the sense we have to specify as a CP here. We did not give any kind of a CP as input here. Okay, this is not available here. So this is only latch. Latch does not have any CP information, and by incorporating this CP, I mean clock pulse, then we will work out whatever the specification you have. Okay, by tomorrow we will look forward for SR flip flop, followed by D flip flop, followed by T flip flop, followed by JK flip flop. Only 4 flip flops are available with us, so we will discuss each and every flip flop continuously. Tomorrow, if it is possible, I have to complete the 2 flip flops for you. Okay, that is